Let us find the sum of special series. Second formula, that is for 1 square plus 2 square plus 3 square plus up till n square. This is your second special series, and we may write it as sigma k square, where k is running from 1 to n. This is second one. Now, to find the formula for this, let us consider the identity. K cube minus k minus 1 whole cube. Let us simplify this first of all. And this we are left with substitute k as 1, 2, 3 and so on in this particular equation. Then the first k1 gives as 1 cube minus 0 cube. At this side we have 3 into 1 square minus 3 into 1 plus 1. Have you got it? Now we have k2, then 2 cube minus 1 cube. This will become 2 cube minus 1 cube. This is 3 into 2 square minus 3 into 2 plus 1. And then k equal to 3 gives 3 cube minus 2 cube equal to 3 into 3 square minus 3 into 3 plus 1. In this I have substituted 1, this is 2, this is 3, and if I go vertically, column wise you may say, or this whole sum will give you these terms. Can you see the pattern? This cancelled out with this cancelled out with this, and the next one with this, and the previous one with this, and we are left with two terms on the left side, that is n cube minus 0 cube. And now you can see it, if we have 3 they are common, and these all terms 1 square, 2 square, 3 square to n square. So if I add column wise, this is 3 times 1 square plus 2 square plus 3 square and so on, this n square. And again we have added these all in 1, and then next these all in 1, that gives you minus 3 into 1 plus 2 plus 3 up till n. And in the last we have all ones, and how many times? Because k is substituting from 1 to n, so these ones will be n times. So this one will again be n times. So what can you see over here? We have, this is 3 times sigma k square, k running from 1 to n. We have studied the properties of sigma, minus 3 times sigma k, k running from 1 to n, then plus n. Now this left side is n cube. Now if I take this term which we want to find on the left side, this is k running from 1 to n, k square as n cube minus, this is plus 3 times sigma k running from 1 to n k and minus n. And if I now simplify as by substituting the special series formula which we have derived earlier, this is plus 3 times sigma k is n into n plus 1 by 2, and this is minus n. So now this is your 3 times sigma k square, k running from 1 to n. Now let me simplify first of all this by taking LCM. This is 2n cube plus 3n square plus 3n minus 2n upon 2, and we have here 2n cube plus 3n square plus n by 2. That means by dividing we will get sigma k square from k running from 1 to n as 2n cube plus 3n square plus n by 6. I can simplify it to get it to remember. This n common, 2n square plus 3n plus 1 by 6, and again if I split the middle term, then I will be getting the factors as 2n plus 1 by 6. So we are having in the last as sigma n square, which we may simply write This has n into n plus 1 into 2n plus 1 upon 6. This is sum of the squares of first n natural numbers. Let us take the third special series, and that is yours 1 cube plus 2 cube plus 3 cube plus up till n terms, last term is n cube. And this is your third special series of the syllabus, sigma k cube, k running from 1 to n. I can write it as this much. Now again, to find the sum of these cubes of n natural numbers, I will consider an identity as in the previous formula we have done. K plus 1 whole to the power 4 minus k to the power 4. I have taken here 4 power, and if I open this with the help of k plus 1 square and n square, or if I use binomial theorem, this will be getting plus 4k cube plus 6k square plus 4k plus 1 minus k to the power 4. This is just the simplification of this expression, and I can see that this is getting cancelled. So we are left with 4k cube plus 6k square plus 4k. This is your 2 raised to power 4 minus 1 raised to power 4 is 4 into 1 cube plus 6 into 1 square plus 4 into 1 plus 1. Next, if I substitute k as 2, this will become 3 to the power 4 minus 2 to the power 4. This is 4, 2 cube plus 6 into 2 square plus 4 into 2 plus 1. And the next same way will go on. And this is your n plus 1 to the power 4 minus n to the power 4 will become 4 times n cube plus 6 times n square plus 4 times n plus 1. Now, if I add column-wise, I will get this whole on the left side. You can again see this getting cancelled with this. This will must get cancelled with the next term, and the same way this will get cancelled with these all terms. We will be left with only 2 terms on the left side. That will be n plus 1 to the power 4 minus 1. And on the right side we can see this 4 is common in all, and we have all cubes a pattern there. So if I take common 4, and this will become 1 cube plus 2 cube plus up till n cube. And in the all next terms you can see over here, this is 6 into all 1 square plus 2 square plus 3 square up till n square. And the next one we can have as 4 times 1, 4 times 2, etc. So again taking 4 common, this will become 1 plus 2 plus 3 up till n. And how many times this one will be, because k is running from 1 to n. So this one is your n times. So 1 plus 1 plus 1, how many times? This again n times. So now I can have simplified this as 4 times sigma k cube. With the help of sigma I can write this. Then this is your sigma k square, k running from 1 to n. I have already got a formula for this. And then this is 4 times sigma k, k again running from 1 to n. And this is your sigma k, again the formula, and this is your n. So if I simplify this as again n raised to power 4 plus 4 n cube plus 6 n square plus 4 n minus 1 plus 1 will be getting cancelled. We are left with this term on the left side as we have done earlier. Now we want to find this expression. So let me take this expression on one side. That will become 4 times sigma k cube, k running from 1 to n. Will be left with this minus this all terms. This is n to the power 4 plus 4n cube plus 6n square plus 4n minus 6 times. This will go on the left side, and minus sigma k square, k running from 1 to n minus 4 times sigma k running from 1 to n, and then minus n. Now you can further see that we know these all formulas for sigma k square and sigma k. If I substitute these formulas, what will I get? I will get on the right side as n to the power 4 plus 4n cube plus 6n square plus 4n. This is minus 6 into n. This whole expression is n into n plus 1 into 2n plus 1 by 6. In the previous we have learned this. Then minus 4 into n plus 1 by 2, and the last one is minus n. This is getting cancelled with this, and this is your 4 times we have sigma k cube k running from 1 to n. Now if I simplify this expression, we are getting this as further simplify this, I will get this as n to the power 4 and 4n cube plus 6n square plus 4n minus 2n cube minus 3n square minus n minus 2n square minus 2n minus n. Now if I simplify it, I will get the terms n to the power 4 and this is 2n cube and this is your 6n square as plus n square only, is 5 square, and this is 4 and getting cancelled. Now this is your n square into n square plus 2n plus 1, that means n into n plus 1 whole square. Now in the last, if I simplify sigma k cube, k running from 1 to n, this I will get n into n plus 1 by 4, that means 2 whole square. And now I am getting this formula for the special series, sum of the cubes of n natural numbers. So we have got the 3 special series formulae. We will make use of this in finding the sum of special series.